How's it going? Chris here with Simply NUC. On this channel, we introduce a lot of different NUCs. Our NUCs, Intel's NUCs, everywhere a NUC. But I don't think we talk enough about what NUCs can actually do. So what can they do? The answer is an amazing amount of things. But today I specifically want to talk about an area where NUCs thrive, and that's edge computing. And to help me talk about this, I'm bringing on Craig Theriac from Scale Computing. Welcome, Craig. Thank you very much for joining me here to explain edge computing to me, because although I may come across as an expert, I'm actually, it's all false bravado. I don't know that much about edge computing. So thank you very much for joining us.
I appreciate you having me on.
So let's get into some questions here. I guess the first biggest question that anyone watching may want to know, and I certainly do, is what exactly is edge computing by definition? And if you could kind of give the explain like I'm five answer, that would be great.
Sure thing. You can think of edge computing as anywhere that is not a traditional data center or the cloud. That's kind of the easiest way to think of it. It's usually running on premises nearby the people or things that are interacting with the data. And so it's, just think of it in that way.
Okay, so these are computers that are, as in the name edge computing, they're at the edge, they're at the very end point, yeah? Is that accurate?
There's really a whole spectrum of it, right? Anywhere outside of a traditional data center, all the way out from, some people have near edge implementations, others have far edge, like right next to the people. And the further you get out to the edge of the network, the closer it is to those people and things interacting with the data. And that's, you really think of it as a pretty broad spectrum there throughout all of that.
So then what are some advantages of edge computing as compared to a traditional data center or the cloud, like you mentioned?
Yeah, I think another way to look at that is, why would you ever run something at the edge as opposed to in a traditional data center or the cloud? There are really a handful of reasons that we see people that are driving to that use case. First one's latency. Being able to make real-time decisions on data. AI oftentimes requires this computer vision types of workloads require something being right there on premises to make real-time decisions. Throughput's another one. If you're generating just so much data that it's either too costly to send to the cloud or primary data center, or maybe it's physically impossible if you're creating that much data, you might have to run on premises. Regulation's another driver that we commonly see, and that's a funny one because it's interesting based on the different industries. It's not just the industries you would expect. It's a pretty broad swath of companies that read the regulation and say, wow, that means that my data has to stay on premises. Autonomy is another one. Despite the fact that we are where we are in the world, not everyone still has a reliable internet connectivity or a reliable connection to their data center where these applications may be running. And downtime for those applications may be downtime for the business. So you need some level of autonomy for running on premises, and that's one of the drivers. And then I would say the last one I see is cost. It's, there's nothing stopping somebody from running their workload in the cloud. It's fine based on the latency. It's fine based on the availability and the autonomy that they have. But the problem is that just the cost of refactoring that workload to actually optimize it to run in the cloud is just insurmountable for some companies. And so for that reason, they run on premises as well.
Okay. It sounds like one of the bigger advantages is if you're in more of a remote area, definitely that's going to help, but also just speed. It's just you have your data right there. It's more on hand. So speed is a big factor. Yeah.
Yeah, both of those I would say are big factors. And, just kind of thinking through some of the use cases of this, we've got a customer of ours that is a seagoing vessel. And this customer is literally taking these giant ships out to sea where they're using, some newer technologies that are pretty cool to have an internet connection, but it's not reliable enough. And so they still need to steer the ship. They still need to, have entertainment options for the employees that are on the ship while they're out for months at sea. And so because they need that autonomy and the speed that comes along with it. Yeah.
I hadn't even thought of that. I always picture people in the desert, never people out at sea, but I guess out at sea is probably a lot more common than people out in the desert. So are there any disadvantages to edge computing?
Yeah, actually, some of it comes right back to exactly what you're talking about. You picture these things in the desert, you picture them at sea. It's, that is not a tier 1 data center. That does not have the cooling of a tier 1 data center. You don't have to deal with salt in a tier 1 data center. There are physical constraints that you just don't have to take into account in a rack mount server going into a secure location that is properly cooled and powered. The second disadvantage that you'll see out there for running edge computing is that, and that's actually, I say it's the second one I mentioned, it's probably the primary, is that you do not have any IT resources likely on site. It's at least limited at most. And so the initial deployment, you really have to think through, like, how are you actually going to get these things physically installed and have them set up to run the applications that you want to run. You've got to deal with break fix problems over time. If something happens to the infrastructure, drive fails, motherboard fails, which we all know hardware fails. Simply NUC makes fantastic hardware, but things still happen out there, and so you need a layer that's going to allow you to stay up and running despite the fact that those failures are going to exist. And then you need a way to be able to respond to those failures without rolling a truck out to the site, because that can be really costly. Connectivity outages and unpredictable demands are kind of some of the other ones, but those may apply really wherever you're running. It's just that if you're running in the cloud and somebody says, hey, I've got a new workload to run, you've got the elasticity of the cloud behind you. You don't have to worry about it. But if somebody says, hey, I've got a new workload that's going to drive top line revenue or drive some new efficiency here, and I want to run it on that infrastructure that you already have on site, that can be a challenge. If you didn't already expect that to be running on the infrastructure, you're going to overload it.
Yeah, I guess it's just a little harder to pivot quickly, but I think from what you've said, it sounds like, though, these are issues that you're probably they have similar issues that you would have with the cloud anyway. It just comes down to, I guess, updating the hardware becomes an issue if your boat's out in the middle of the Indian Ocean,
Right. Yeah. If you have to schedule the drive replacement to meet you at the port where you're coming in, that's a little different than sending somebody back to the very cool, well-powered data center room right next door.
To you, what is the most exciting thing, potential-wise, for edge computing?
I think I'm really excited by all the advancements that we're seeing in artificial intelligence right now. I just, in the last year or so, it's gone from kind of a toy to a really useful set of technology. And what we're starting to see out at the edge is that the kind of applying those inferencing models, we've been doing all this great training in the data center and in the cloud, and now we're going to take what we've learned from that and apply it in edge use cases like this. I'm really excited by that, because I think it's going to impact every industry, whether that's in retail, kind of being able to accurately capture real-time customer behavior and respond to that proactively, whether it's theft prevention, that sort of thing, or in manufacturing IoT or industrial IoT type of workloads where you got to have on-site processing in the factories, and you've got to monitor the machinery for potential breakdowns. Like, all of those types of things become available when you're able to have that intelligence built right in to the application, which is running on the infrastructure, which is right on site.
How do, at scale, I mean, you've talked a little bit about your customer that's out at sea, but how do your customers leverage edge computing?
There usually is some kind of legacy workload that they've always had out there. At scale, we've had a lot of success in retail. We've had a lot of success in those types of remote deployments, like those ocean-going vessels, and in manufacturing and healthcare and others. And every industry is there are legacy workloads that they've always had, and then there's some new workload that is coming on the scene right now, or at least coming down the pike, that the IT infrastructure teams that are dealing with the infrastructure on premises for these workloads are starting to take into account. And I would say they're using the infrastructure today to put in place what's needed for what might be coming tomorrow. And while you and I are talking about this, I think this is really cool. I love the coolness factor of just edge computing in general. I think so many interesting things are going to come from it, but people don't buy based on cool. They buy either to increase the top line revenue or to decrease the costs associated with running the business. And it's usually one of those drivers of why they're actually going to be putting something in place, met with I have to take into account the legacy thing that has been there for the last 10 years that we need to get onto the latest and make sure that it continues running, but it has to run right alongside that newer container-based workload that's going to be restructuring, refacing the entire business.
Yeah. Well, I mean, I would buy it if it just looks cool. So if that's any help, but I'm also not a large corporation that's trying to buy, hundreds of applications or solutions. That was all very interesting. So thank you very much, Craig, for coming on and answering all my questions. I would love to have you guys back some other time to talk about other stuff too. You're very easy to talk to, but I learned a lot about edge computing. I hope anyone watching learned some too, and we'll see you on the next one.